Hi, my name is Michael Riego and I'm recording this video as my course project for my subject load testing CS6303. Okay. I have chosen planning an effective load test as my topic for today. Okay. So before we jump into the topic, I would like to give you a short overview about performance testing. So a performance testing tool will help you to measure the performance parameters of an application. This application can be in any type of application or can be built on any set of protocols. And this can be very well accommodated with the new tool called as a load runner. Load runner has been in existence for a long time, but it is evolving from time to time. So this video will show us how to plan an effective test. Performance test planning. This is basically to understand how performance testing is different from functional testing, and also look at some of the thought process. How do you gather information about the system you are planning to test, and some are their SLAs and requirements. Performance versus functional testing. It is very important to understand how performance testing is different from functional testing. And this will help you a lot because the thought process of doing performance testing is much different from functional testing. So this comparison will really help you to plan for a performance testing. So let's take a look at some of the stuff to see what's the difference and give you better understanding of it. Validate system behavior. So in performance testing, basically you are validating system behavior under the hood. On the other hand, in functional testing, you validate applications functionality. Okay, so you really don't care about the system, how the system behave and the performance or response time. You validate the application system based on system requirements. In performance testing, analysis is very complex because you look at the matrix from the application server middleware, database, and CPU utilization, memory disk I/O, and a lot of other matrix within the database. If you're using Java, .NET, or .NET framework, you look how the garbage collection is working and memory usage and all these stuff. On the other hand, in functional testing, it is very simple. You have to test case basis on your system requirements and coverage, and basically run the test either pass or fail. You don't need a lot of analysis on that sense. On performance testing side, requires adequate system resource. So what do I mean by that? Based on the type of load you're going to run, like number of users, transactions, and if you're comparing that to some production system or some SLAs you have. So you have to have a system that allow you to run that load and get the measurements out of it. On the other hand, for functional testing, you don't really need a full-fledged system. You just have to have a small system functioning enough so you could manually or even the automation tools walk through, or whatever the scenarios you need to run, you can run them. Okay. One of the difference between performance and performance testing and functional testing is performance testing is you need to have an in-depth knowledge in system. You are going to test because you need to understand what are different nodes and which are monitoring point. So it's like tapping into the database and middleware, how many servers are there, is there any load balancing being happen. So you have to take a look on all of those stuffs and the architecture system. So, and how you're gonna manage a system, because you basically look you are basically looking for bottlenecks throughout the system. So only way to get that information is if you were monitoring it or logging some kind of lagging on it, lags on it. On functional testing, you just need the basic application knowledge, and you don't really need the in-depth architecture of it as far as the testing goes, because you're trying to validate the business requirements basically. For performance testing, test load are stress oriented. Basically, the scenarios are designed based on specific goals. If it's endurance testing, you're trying to do a failover that stresses system to a point to see where the breakpoint is. While the functional testing point of view, tests are basically functionality oriented, so you try to get as many different paths and negative testing coverage possible based on business requirements. In performance testing, we require plenty of testing, and we require plenty of data, because you're going to be running a lot of users and multiple aggressions, each user running. So you need to have a pre-staged data that will be used by your different scenarios. While in functional testing, test data is minimal because each test cases uses one script and uses multiple datasets. System monitoring is required to pinpoint issues. Means all of the different parts of systems or subsystems, they are part of performance load testing. You need insights to those systems. The only way you can go inside of it, you should have some kind of monitoring on it. So while you are running a test, during the test or after the test, you get something kind of data that shows you the performance of the system. On the other hand, in functional testing side, system monitoring is not required as long as the system is behaving as per the business requirements. In performance testing, it requires automation tools to simulate the load, while in functional testing, automation is not required. Objectives. So on this video tutorial, our main objectives are the following. We define measurable goals for your load test, gather preliminary information before load testing your system, organize system information effectively, use gathered information to plan a load test, test planning and thought process. Understand the application, architect, and the testing scope. If you look at nowadays, you need to know if they are service-based or they are taking to multiple or they are talking to multiple systems like PeopleSoft, Salesforce, or even homegrown tools. So you need to understand what scope it is, what part of the application you will be testing, what is in scope, what is out of scope, what is the architecture, how many application servers, is there any load balancing happening, and how many database or sort of kind of information you need. Identify application functionality, usage, and SLAs. What functionality that happens within the application, what are the usage, how they use their applications. Test environment size comparable to production, app server, DB size, and etc. So once you get the information, the next step is to identify the differences between the environment size, between the test environment and the production. Okay. Develop workload based on environment size and usage pattern. After getting all those informations, now you need to figure out a number of test cases, type of test cases based on user behavior. Each group type will be different, and based on that group type, what kind of functionality they will be executing during the load test, what kind of data they'll be using, how much data you will need for that time period, of the test, and you need to figure out how long the test will run. Identify and stub out of scope integration points and subsystems. So when you are testing a system or an application, there are going to be some integration point with the other system or application, and those applications may not be in adequate size to sustain the load we are going to generate with that application. So we need to figure out how to stub them out, because they will be your bottleneck. Because if your system is depending on that subsystem, and that subsystem is not adequate to handle the load, you won't be able to push the full load through, and that is going to be a bottleneck. Develop iterative test plan. So pre-stage data, DB snapshot, etc. Because in performance testing, you may require to perform a multiple performance testing and executions to figure out an issue, because you'll be playing around with the application settings in connection pooling and all that stuff. So because you will be doing multiple tests maybe per day, so if you're pre-staging a data and it takes a long time to pre-stage a data, so the workaround is to pre-stage the data and take a database snapshot and have a restore plan after each test. Each test runs, you restore the database at restore point where you can quickly ready for the next versions of the test. Create a monitoring and reporting strategy. Creating the monitor and reporting strategy is basically if you do have access to the database or middleware in an application server, and you can add the matrix, then the load runner itself, so you can put those monitors. While for some reasons, if because of security reasons, you don't have access to this, so you need to talk to your DBA to put monitors in place, and talk to application developers and whoever could help you with monitoring different parts of the system, because you will require data to do your analysis. Without it, you will be running your test in the dark. Establish an application baseline. So after said and done, all the informations are there, from smoke test to shakeout test. You are really ready to start testing. The first thing you need to do before you start running all your testing durations is to get a good baseline. And that is very important, because that baseline will serve you from each test every time you are making changes with configurations in application or database middleware. So each time you will make a change, if you are tuning it, it will help you compare with the baseline. It will tell you if it's gotten worse or better. And the last one is application tuning. Establish goals. Okay. So this is the load testing process. Number one, plan a load test. We define goals, analyze system, gather system usage data. Step 2, create virtual users. Record scripts and turn scripts into V users by adding test data and user behavior. So scenario creation is the third one. Create scenarios based on your goals. Step number 4, scenario execution. Execute scenarios for testing first, running 100% and overloading. Fifth, result analysis. Analyze result data and pinpoint bottlenecks. So after that, you can tweak the system based on your analysis. So fine-tune system based on analysis data and rerun the scenario. Rerunning the scenario indicates whether performance has improved and whether goals has been achieved. Define your goals. Conceptual goals should be outline all your load test objectives. Example of conceptual goals. A high priority example is the responsiveness of a search function. Are you able to get results within the reasonable time? A second example is the system administrator's concern that the update transaction can function during heavy usage. In the initial stages, documenting goals that cannot be measured will allow a later filtering to create more focused goals. So we proceed with the business process. A business process is a set of actions or user steps performed within an application to accomplish a business goal. Mission critical business process. Business processes that are crucial in day-to-day operations. Heavy throughput. A business process might not be a mission critical, but a very popular. Dynamic content. Dynamic content consists of server requests that are customized for each user. Recording business process. Mission critical, or examples of them are e-commerce transactions, downloading orders, okay, get info from application experts and management team. Identifying business process to a record. Examples. This is the example of the record as shown in the diagram. Defining preferred response time. Okay, this is a sample image of business process, user steps, and preferred response time. Documenting user steps and input data. Okay, this is the login page. Determining valid test data to user. Okay. Okay. Valid input data comes from three sources. Master data, also known as application data. Data is resident in application database. Example, ID, numbers, and passwords. User-generated data originates from the user. Example is new unique ID or email. External data. Data is unknown before the application runs. Example, confirmation and purchase order numbers. Gathering data, obtaining customer locations. User websites, domain report log, consult database of customer addresses. Create estimated model if application is not yet live. Goals, quantifying load testing goals. Okay. Example of conceptual goals. Search should be fast enough. Example of quantitative goals. Search transaction time of 8 seconds or less during peak hours for 5,000 concurrent users. Another example of conceptual goals. Confirm that update still works under heavy traffic. Example of quantitative goal. Attain 200 concurrent users for the update transaction during peak time, 12 noon. Monitoring. Planning system monitoring. Effective system monitoring involves answering key questions. Does the system have statistical information that will help in troubleshooting performance issues? Who understands this information? Who can make changes to the system? Who has the appropriate security permissions for that system? Environment. Using a test environment. Okay. A test environment allows data to be written, read, and destroyed without affecting production users. Allow test system to be rebooted during test runs without affecting production users. The test environment should mirror the production system. Needs business processes that are functioning correctly. Should include benchmark runs. Must contain sufficient hardware to generate the load test. Benchmark. Executing a benchmark run. To validate that the test environment has enough available hardware, benchmark the business process against the testing hardware. Take business process and execute small number of users against the application. Validates the functionality of the business process, potentially exposes unknown data dependencies. Evaluate the testing infrastructure against the footprint. Do you have enough hardware to generate the user load? Do you have enough memory? Do you have enough CPUs? And that's all for this topic. Thank you for listening, and God bless.